if the limit of f of x over x as x approaches 0 is equal to 1, then we want to show that the limit as n approaches infinity of the sum from 1 all the way up to n of f of 2i minus 1 over n squared times a is equal to exactly a, where a is positive. And before that, I'm going to first prove this lemma, that the sum from 1 all the way up to n of 2i minus 1 over n squared is equal to 1. So here's why. Sigma I from 1 all the way up to n 2i minus 1 over n squared. First of all, n squared is just a constant, right? It has nothing to do with I, so I can just take it out. So 1 over n squared times sum from 1 all the way up to n of 2i minus 1. And then I have 1 over n squared times, again, I can just split up these two sums, right? So then I have to take out the 2 out here. Sum from 1 up to n of I, right? Then the other sum minus sum I from 1 to n of just 1, right? So that is equal to 1 over n squared times 2 times, what's the sum from 1 to n of I, right? We have the formula. That is half of n times n plus 1, right? The sum of the first n natural numbers. And minus this sum, right? We don't have 1 here, but we still have n, many of them, right? So we have minus n, right? What do we have now? So 2 times that, right? 2 and 2, they can just cancel out. And I'm left with n squared plus n, right? Expand the brackets. Minus n, so the n's are gone. I only have n squared inside this bracket, right? So 1 over n squared times n squared. I just have 1. So this is proven. And so next, my goal is to prove this limit is equal to a. Right? In other words, I want to prove that for any given positive, right, can I find a capital N so that when little n is bigger than capital N, can I show that the absolute value of the sum from 1 to n of f of 2i minus 1 over n squared times a minus a, right? That is my limit, absolute value. Can I show this absolute value is smaller than epsilon, right? This is what I want to prove. Now, all I need to prove is that, first of all, I'm going to rewrite the a into a times 1. 1 is equal to this sum, right? I've proven this identity. So I can rewrite it into just sigma from 1 to n of f of n squared 2i minus 1 times a minus sigma from 1 to n 2i minus 1 over n squared times a. Right? Times a. I just take a inside this sum, right? A is constant, so this is allowed. The same thing. Can I show this is smaller than epsilon? Right? In other words, if I can combine the sum, all I need to show is that this absolute value of the sum from 1 up to n of f of 2i minus 1 over n squared times a minus 2i minus 1 over n squared times a. absolute value smaller than epsilon, can I show this result? Right? So in other words, can I show that if I just take the absolute value inside the sum, right? I just need to show that because this absolute value is smaller than I from 1 to n, take the absolute inside, absolute value f of n squared 2i minus 1 times a minus n squared 2i minus 1 times a. Absolute value, right? This absolute value is smaller than or equal to the absolute value, then take the sum, right? Then all I need to show is that this is small enough, right? So this is smaller than epsilon, and that is smaller than this. So this will be smaller than epsilon, right? This is what I want to prove. Now, since I've proven that this sum is equal to 1, right? So next, as long as I can show that every I, so that for every I, the absolute value of f of n squared 2i minus 1 times a minus n squared 2i minus 1 times a absolute value is smaller than n squared 2i minus 1 times epsilon. All right, can I show that? If I can show that, then when I take the sum from 1 all the way up to n, right, I from 1 all the way up to n as well. So this part will become just 1 times epsilon. Then this will be automatically true. Right, so this is my next goal. Now, in other words, all I need to show is that I can divide both sides by 2i minus 1 over n squared times a, right? So therefore, on the left-hand side, this part will become 1, right? Divide by itself. And this part will become. So all I need to show is that absolute value f of n squared 2i minus 1 times a over n squared 2i minus 1 times a, right? Minus 1 absolute value is smaller than epsilon over a, right? Divide by this thing, right? So therefore, there's no a here, so I have to divide by a. Epsilon over a, right? The reason is because a is given to be positive, and 2i minus 1 over n squared is automatically positive because I is bigger than 1, right? Bigger than or equal to 1. So this is automatically positive. So this is still true, right? So in other words, I can just treat 2i minus 1 over n squared times a as x, right? Because I have exactly the same x down here and inside the bracket here. So according to the limit, given condition, right? This limit is equal to 1. Therefore, for any given epsilon, right, I'm going to use this special epsilon, right, derived from here. Here, I'm just randomly given. Once given, I fix it, right? For this fixed epsilon, I can find a delta that's positive, so that x minus 0 absolute value, in other words, x absolute value is smaller than epsilon and bigger than 0. Right, deleted the neighborhood, right? Not allowed to be 0 because I'm talking about limit. So under this restriction, according to the given condition, we can always have the absolute value of f of x over x minus 1 can be smaller than epsilon. Epsilon over a, actually. Right? It says any positive, this inequality is true. How about this special positive? Of course, still true, right? So I'm getting very close to my desired inequality, right? Epsilon over a, epsilon over a. And I'm just treating this as my x as long as x is small enough. So in other words, can I make sure that this guy is small enough? Right? In other words, all I need to show is that, first of all, remember this whole thing is positive, right? Now, all I need to show is that 2i minus 1 over n squared times a. I don't need the absolute value. It's already positive, right? Treating it as x. As long as I can make sure that this is small enough, right? Smaller than delta, then this inequality is true. In other words, this inequality is true, right? This is just like x. So can I make sure this is small enough when n is big enough? Of course. So first of all, this is smaller than, if I replace I with n, it's become bigger, right? So 2n minus 1 over n squared times a, right? Perhaps less than or equal to. Now, here I subtract 1. If I don't subtract 1, I become bigger, right? So this is further loosened to become 2n over n squared times a. What is that? That is just 2a over n, right? So I have 2a over n. So as long as I can make sure that this is small enough, smaller than the delta we've just found, right? So in other words, as long as we can make sure that little n is bigger than, divide this delta over, right? We have 2a over delta, right? So when little n is big enough, this can be small enough. So this can be small enough, right? So when this is small enough and also bigger than 0, of course, obviously. So in other words, the absolute value of this itself is bigger than 0, smaller than delta, right? So this condition is satisfied, right? It says as long as the absolute value of x is bigger than 0 and smaller than delta, then this inequality is true, right? We've satisfied this condition. So that means just replace x with this stuff, right? This inequality, therefore, is true, right? According to the given condition, right? As long as little n is big enough. So we've really found a capital N that is equal to the floor of 2a over delta. Right, where does this delta come from? This delta comes from the given epsilon, right? From this epsilon, we've derived epsilon over a, right? So we made sure that this can be small enough, smaller than epsilon over a. And where does this epsilon come from? This epsilon comes from any given epsilon at the beginning. Once given, we fix it, right? So therefore, when little n is big enough, right? We've just made sure that this inequality is true, right? Based on the given condition, right? So since this we've shown to be small enough, so therefore this is automatically true, because each step I said, if we want to prove this inequality, all we have to show is this inequality. All we have to show is this. All we have to show is this. All we have to show is this, right? Then all we have to show is this. Right? This is from dividing by both sides by this guy, right? So this is true. Therefore, this is true. This is true. Therefore, this is true. Therefore, this is true. Therefore, this is automatically true. Right? Like I said, the reason this implies that is because we take the sum from 1 to n, right? Right-hand side, what's going to happen is that I sum from 1 all the way up to n. This part is just this part, right? Automatically sum up to 1, right? So therefore, I can just derive epsilon on the right-hand side, right? Just like I desired on this equation, this inequality, right? And summation from I from 1 to n is what I have on the left-hand side, right? This is what I desire. Right? So this is true, so therefore this is true. So I've really shown that this inequality is true, right? Since this sum is 1 times, like I mentioned, right? So I've rewritten A into this seemingly complex expression, but somehow it can help us, right? Even though it seems very complex. And so this inequality implies the exact definition. That's exactly the definition of limit, right? So this is close enough to A, right? Meaning this limit is just A as n approaches infinity. Right? So n approaches infinity. This limit is really A.